All right, guys, how's it going? Well, we have finally made it to the quadratic equation. And what that looks like is it is y equals, and then forgive me as I get all my colors out, equals a x squared plus b, sorry, quadratic function, not equation yet, bx plus c. This looks a lot like what you guys have been factoring, right? So that's why we are bringing it in. So the quadratic function is y equals ax squared plus bx plus c. When graphed, a quadratic function creates a U-shaped curve called a parabola. And the vertex is either the highest or lowest point of the parabola. The vertex can also be called the the maximum, in which it would kind of make an upside down U, or the minimum, in which it would kind of make a smiley face. All right, so to find the coordinates of the vertex, you're going to think of it as an X and a Y. You're going to use this equation to find H, which is technically our X value. You're going to say H equals, and it's going to be a fraction, negative B, so whatever your B value is in that equation will go on top, divided by 2 times whatever your A value is. And that'll be, remember, H is always going to be the X value of the vertex. All right, and then to find K, which is your Y value, you're going to plug the H value in. You're going to plug that H value in for X. Plug H value in for X back into this original equation. So you'll get your H and you're going to take it in and plug it in for X back into your original equation. Pretty exciting, huh? So, and don't forget that this is the Y value of your vertex. So let's go ahead and try it on this first example. Pay attention to these example guys, because this will be the first week that I'm not going to do half of your homework for you. You're going to be in charge of it yourselves. So if I look here, I would see that my A value is equal to 1. Remember, we always have a little imaginary 1 right there. My B value, so A is this first one. My B value is right here, which is a 6, so B equals 6. And my C value is equal to 5. So I'm going to go ahead and I'm going to solve for my vertex. It says find the vertex of the parabola given the equation. So I'm going to go ahead and say that H equals negative 6 over 2 and then times 1, which that'll simplify down to negative 6 over 2, which equals negative 3. So H equals negative 3. Now to find K, I'm going to plug it back into that equation. So I'm going to say K equals negative 3 squared plus 6 times negative 3, right? And then plus 5. All right, well, negative 3 squared is 9. 6 times negative 3 is negative 18. And then plus 5. And when I Find all of those terms. I end up with k equals negative 4. And so my vertex is equal to negative 3 and a negative 4. Okay, not too bad, right? So let's look at this one. We'll go ahead and we'll see that A is equal to negative 1. B is equal to negative 4. And C is equal to 12. So we'll plug that into the equation, right? We're going to say H equals a negative 4 over 2 times negative 1, which is 4 over negative 2, which equals negative 2. So we know that H equals negative 2. Now we're going to go ahead and we're going to take that and plug it back in. So we are going to say K equals negative, right? Because there's a negative x here, but then it's a negative 2 also, squared minus 4 times negative 2 plus 12. So right here, I just want you guys to be really careful because it's a negative 2 squared, but then there's another negative. So I want you guys to remember to use GEMDOS, our order of operations. So that is going to become a negative 4, right? Well, positive 4, but a negative, minus 4 times negative 2 plus 12, which would become negative 4 plus 8 plus 12, which K then would equal 16. So our vertex, we know, is going to be a negative 2 and a positive 16. Okie doke, guys? Okay, now we're going to talk about the axis of symmetry, which you might hear me refer to it as AOS, axis of symmetry. You might hear me call it AOS. So the axis of symmetry is a vertical line that divides the parabola into two equal parts. It just cuts it right in half, that are reflective of each other about the line of symmetry, right? So it's its line of symmetry, it cuts it in half. It'll be the same on one side as it is on the other. The axis of symmetry is always an equation of a vertical line. And remember, vertical lines, that means your answer will always be x equals a number, right? Vertical lines, because they're cutting through the x-axis. So your answer will always be x equals some types of number for your axis of symmetry. So to find the equation of a line for the axis of symmetry, this should look familiar to you. It's going to be x equals negative b all over 2a. And it should look familiar to you because it's the same as the x value of your vertex. So this equation is the same as the x value for your vertex. Okay, so this equation should look really familiar to you. X squared plus 6x plus 5. It's the same equation here. We already found the x value of our vertex, right? We already knew that h equals -3. So we now know that our equation for the axis of symmetry is simply x equals -3. This is the work from the x value of the vertex in number 1. Okay, so this equation looks really familiar too, right? -x squared minus 4x plus 12. Looks familiar, looks familiar, looks familiar. So take a minute and tell me what you think x equals then for this one. You can pause me and look. Well, if you look up here, you'll see that our h value is -2. Well, it's the same thing for whatever our axis of symmetry is. So x is going to be equal to -2. All right? You don't need to redo it. You're going to get the same answer. So this is the work from the x value of the vertex in number 2. Okay, so that's page 1. Let's go ahead and move on to page number 2. The Y-intercept. Okay, so the Y-intercept, same thing that it's always been, is the point where the graph crosses the y-axis. Okay, to find the coordinates of the Y-intercept, you are going to plug in 0 for x and solve for y. But a little hint here, the y value will always be the c value in your equation. So just remember, see this 0? If it's a y-intercept in the ordered pair, the x will always equal 0, right? Okay, so to find the y-intercept, we plug in 0 for x. But a hint is that the y value will always be whatever our c value is. Well, if we look at number 1, our a would be 1, our b would be 6, and our c value is actually equal to 5. Okay, so let's test this out then. Let's go ahead and plug in 0 for x. So we're going to say y equals 0 squared plus 6 times 0 plus 5. Well, 0 squared is 0. 6 times 0 is 0, and then plus 5. So y equals 5. Oh, we didn't even have to do all that work, right? We just see that c is 5 and our answer is 5. So to write our y-intercept, it would simply be 0 because our x value is always 0, and then 5. And if we look right here, we see, oh, our c is equal to 12. Then this c equals 12. We know that our y-intercept is 0, 12. Okay, now x-intercepts. That's the big thing, right? The x-intercepts are the point where the graph crosses the x-axis. And the x-intercepts are also known as roots, zeros, or solutions. Okay, roots, zeros, or solutions. That's a big thing. All right, that's something you want to remember. It might come up as a question at some point. So a quadratic function can have 1, 2, or no solutions. It doesn't have to touch the x-axis, right? It might not cross down here. It can cross it at only one place. It can cross it at two places like it does here, or it can not cross it at all. You can find the x-intercepts of a quadratic function by graphing, factoring the quadratic formula, completing the square, or square roots. Today, it's all graphed for us. So the first thing that we're going to look at is right here. We talked about x-intercepts, so I'm going to go ahead and point those out first. My x-intercepts are, or my solutions are a -5, 0, and a -1, 0. So -5 and -1, 0. All right, my axis of symmetry. Well, I look right where the vertex is down here, and I'm going to draw that line, that symmetric line, all the way up. This right here is my AOS, my axis of symmetry. And remember, I look at whatever my x value is, and right here it crosses at a -3. So I would say x equals -3. My y-intercept, it looks like it is crossing right about here on the y-axis. So my y-intercept is going to be 0, 5. All right. And because right here, it's an upside down, or it's a U, this would be my minimum. All right. This is a minimum because this is the lowest it's going to go, the minimum point. So a minimum, if I can spell it correctly. All right. And then my vertex is going to be a -3, -4. Okay. So when A is greater than 0, that means A is positive. The parabola will open upwards. See how right here, our A is technically a 1, it's greater than 0. And the vertex, so whenever it's opening upwards, like the U, a smiley face, the vertex will be a minimum. And then we're back to domain and range of a graph, if you can remember from first semester. So the domain will always, always, always be all real numbers. So it's going to be -infinity, positive infinity. And here's your little hint. A quadratic function will always have a domain of all real numbers. A quadratic function will always have a domain of all real numbers. Okay, our range is the tricky part. So remember, guys, we always start at the bottom with our pen, and we see that what we bump into first in that graph, and we see that it's a -4. So that would be a bracket, right? -4, and then it's going up and on forever and ever and ever. So it's a positive infinity with a parenthesis. Okie doke. Let's move on to this next example. All right, we see that our A is 1. Okay, and this parabola, because A is technically less than 0, A is negative, the parabola will open downward. And the vertex will be a maximum. That means that's the highest it's going. That's the maximum point. Okay, so let's go ahead and label our vertex. Our vertex is -2, 16. And if we know our vertex, then we know our axis of symmetry, right? So our AOS is x equals -2. My y-intercept is right here where my parabola crosses the y-axis. And y-intercept is going to be 0, +12. And then the two places where it crosses the x-axis. So my x-intercepts. The first one is -6, 0, and the second is a +2, 0. Right, and that's kind of about it for that graph. But then we talk about the domain, and remember, it's all real numbers, so it's a -infinity and a +infinity. And then the range. Well, we start at the bottom, and the first thing we hit is it going downwards for forever. So that's going to be a -infinity. And then we go up, 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 and we see that it stops at a +16. So, +16. Let's see. Let's think about that because you're always thinking of the range. The range will always be -1. And the highest y value, the max y value. Okay, so the range will always be -infinity and the max y value. Back over here, the range will be, oops, that's supposed to have a bracket on this one, sorry. So over here, this is supposed to be a bracket. So the range for this one, because it opens upwards, will always be our minimum y value with the bracket, whatever your minimum y value is, and then a +infinity. And that's it for these notes, guys. So that is the quadratic graphs and their properties. Come to office hours if you have questions. Please, please, please. Okay, bye.